researchers and everyone present here. I am Meera Kwalula from the Department of Mechanical Engineering, Kuwait. Today I want to share one of my recent research, and that is the development of S10 plus simulation model to evaluate the viability of pyrolytic oil from waste plastic, which is conducted by me, the main author Sakib Kore, under the contribution of Dr. M.D. Mizanur Rahman. As you know, waste plastic is increasing day by day. It is creating a various problem. In the last year, more than 350 million tons waste plastics have been produced in the whole year. Among them, only 9% of waste plastic is recycled. Most of the waste plastics are being landfill, which is harmful for our environment. The main objective of our research was to develop an S10 plus simulation for the pyrolysis process, and also there are various types of plastics. That is, among them we have chosen only three types. That is HDPE, LDPE, polypropylene, and the mix of these three. So, in the methodology, we have S10 plus simulation assumptions, feedstock preparation, pyrolysis process, sensitivity analysis, and the reactor models. At first, we have taken proximate and ultimate analysis to take the physical and elemental properties of plastic so that we can know how it actually characterizes during deformation. We have also taken sensitivity analysis. In the sensitivity analysis, we have taken three parameters, that is called temperature, particle size, and the retention time. In the temperature, we have taken 450 degrees centigrade to 600 degrees centigrade, and the particle size we have taken 1 millimeter to 10 millimeter, and the last but not the least, we have tried to take the small particles as much as we can. This is the whole simulation process of our pyrolysis process from the waste plastic to the oil. This whole process, at first we have used waste plastic, then crusher, dryer, and grinder. Grinder, it is in the grinding process we have reduced the size as much as we can. Then on the reactor we have used nitrogen gases so that the oxygen can be removed from the system. Otherwise, if the oxygen is present in the experiment, the pyrolysis cannot be done properly. And lastly, solid separator, we get char, and another, if the vapor is there, we call condensation and solid separator, thus we get syngas and oil. This is the whole experimental simulation setup of our research. Results and discussion. Since we have taken three types of plastics, HDPE, LDPE, and polypropylene, also their mixtures, right now we are watching some graphs. Since there are three parameters, at first we have effect of temperature. In the temperature graphs, we are seeing if the temperature increases, the yield at first increases. That means we get oil yield as much as we can. But when it almost crossing the 525 degrees centigrade, then the oil yield is decreasing day by day. On the other hand, when the temperature crosses 5 to 5 degrees centigrade, the syngas increases. Since the syngas increases, we cannot get enough type of oil yield, which will harm our process. That's why the optimum temperature for pyrolysis is 5 to 5 degrees centigrade. This has been told here, when the temperature from 0 to 5 degrees centigrade, the char yield decreases, but when it is crossed 5 to 5 degrees centigrade, the maximum oil yield we get, but when it is crossed, then we get enough syngas due to the secondary cracking. We have also the effect of retention time. So from the retention time, at first 1 to 3 minutes we get the highest oil yield. When the time is being crossed more than 3 minutes, then the oil yield decreases because there is further decomposition. Since further decomposition occurs, the syngas quantity is also increased. As a result, we can get enough oil. Then we have the particle size effect. In the particle size effect, we have tried to take as much as less size particle so that it can help our experiment. If we take bigger particles, it will reduce the surface area. Moreover, the heat distributed will not properly. So we have taken smallest particles, but 2 to 3 millimeters particle size is enough for pyrolysis process. In the optimum result, we can get the temperature of 5 to 5 degrees centigrade, particle size was 2 to 3 millimeters, and the retention time at 3 minutes. In this optimum result, we get polypropylene gives the highest pyrolytic result. Then we have LDPE, last but not the least, HDPE. Why polypropylene gives highest pyrolytic weight? Because it has a simple structure. Moreover, it has the highest hydrogen carbon component. Since it has the highest hydrogen carbon component, we can get enough kind of oil. The LDPE is greater than HDPE, I mean low density polyethylene is greater than HDPE because LDPE has amorphous composition. On the other hand, HDPE is crystalline structure, which is not good for a pyrolysis process. In the conclusion, it can be said that spectral simulation is an effective tool for the pyrolysis process, which can, if we use it in the future experiment, physically, we can get a sustainable environment. Thank you so much.